Okay, so section 3.7, it's on solving systems of equations by graphing. So first off, we need to talk about what a system of equations are. System of equations are just two equations, two or more equations with the same set of variables. So both equations would have x's and y's in them, or a's and b's, but system will have the same set of variables. A solution to the system of equations is the single point where the two graphs intersect. So in previous lessons, we learned to write the equations so that they may be solved for y or put into the slope-intercept form. So we solved it for y, and by solving it for y, it became the slope-intercept form. So when we do that, we can easily graph the equation, and we do that by using the y-intercept, and then from the y-intercept we use the rise and the run from the slope. So let's take a look at how this looks. So here I have two equations. They're both solved for y equals y equals. So we're going to look at them and we're going to take the equations apart. We're going to identify what the y-intercept is. And in this case, it's -1. It's that plane number. And we're going to identify the slope. And the slope is always found right in front of the x, not the x itself, but right in front of the x. And because there is no number there, it's an implied 1 because we have a 1x. 1y equals 1x minus 1. We don't normally put the ones in front of there or say them, but we need to have that 1 for our slope. And because it's a whole number, we're going to make it into a fraction so we can talk about rise and run, and any whole number can be made into a fraction by putting it over 1. So this top part is going to be our rise, and the bottom part is going to be our run. So how do we graph it? Well, we go to the y-intercept. Here's our y-axis. So on our y-axis, our line is going to cross that y-axis at -1. And we put a point. And then from that point, we use our rise and our run. So we rise up 1 and we run to the right 1, and we put another point. And once we have those 2 points, we connect them, and we see that's our line graphed out using the y-intercept and the slope. So once we do that, we said a system is two or more equations. So there's one equation. Here's the second equation. Once again, it's already solved for y. So our y-intercept is this plane number, -2. The slope is 2. It's an integer, so we make it 2 over 1. We go on our y-axis at -2, and we put a point. And then from there, we rise up 2 units and run over 1. So rise up 2 units and run over 1. And we put a point. Now, in these two cases, they intersect at the intercepts, both the x and the y intercepts. It's not always going to be the case, but for this graph, it is. Now, to solve our systems of equations, to find a solution for them, I'm going to take this line right here, and I'm going to move it down to this graph. And we said we intercept at -1. And then I'm going to take this line and move it down here. And that intersects at -2 and up 2 and over 1. And we can see that our lines intersect right here. Oops, I didn't mean to move that. Our lines intersect right here. And that point is 1, 0, and that is our solution. And we can check our solution by going back up to these equations and plugging them in. So 1, 0 we said was our solution. So 1 is the x and 0 is y. So if I go up here, 0 equals 2 times 1 minus 2. 2 times 1 is 2. 2 minus 2 is 0. 0 equals 0. Works for the second equation. Let's go to the first equation. Y minus x equals a negative 1. We're going to plug in 0 for y, a 1 for x. 1 minus 1 is 0, and we get 0. So it works for both of them. So this is our solution. It's where those two graphs crossed. Now, if we go to this one, these equations are not solved for y yet, so that's the first thing that we have to do. So if we want to solve this for y, I'm going to take this x term, move it to the other side of the equation. When I move it across the equation, the sign of that term becomes the opposite. So it was a positive 4x, it becomes a negative 4x. There's no number over here, so I'm just going to put the plus 0 to save the space or the place of the y-intercept. Over on this equation, I'm going to move that x term across. It's negative now, so it becomes a positive x plus 3. Rather than dotting or graphing them on separate lines or separate graphs, I'm going to graph them on the same graph right away. This first one I'm going to graph in red. It has a y-intercept of 0. Oh, maybe I'm going to graph it in blue. And then a slope of negative 4. So the slope is negative 4 over 1. Y-intercept is 0. So 0, go down 4 units, and over 1. We're always going to move to the right, and we're going to let the sign of the slope determine whether we go up or we go down originally. So there's that line. This other line has a y-intercept of 3. I am going to change the color now. Y-intercept of 3 and a slope of 1. So once again, it's 1 over 1. So from there, I'm going to rise up 1 and run over 1. And I get this point, that graph. Now, if I were to really use a straight edge here, which I can get a ruler. Math tools, there we go. Ruler. If I place this ruler at 0.00, rotate it some more back there. It's pretty close, except I took it off of there, so I have to move it some more. That looks pretty close there, and I can draw my line using that straight edge. Okay, so I can see with that straight edge there that those points intersect right there, and the coordinate of those points I would say is probably a negative 3/4 and maybe 2 1/4. That's the way where they're looking, the way they're looking for me here. I know that it goes through that point and it goes through this point. So really halfway it should be right there. And I know that this one goes here and it's going to go through that one. So yeah, it would probably intersect. And we'll leave that. But we can check that and see if that works for the two equations. So let's look for the first one. 4 times what my x is. negative 3/4. Plus my y, 2 1/4, equals 0. So I know that my 4's cancel. I'm left with negative 3 plus 2 1/4. Now negative 3 plus 2 1/4 is a negative 3/4. It doesn't quite equal 0. So this is not the exact solution, but according to my graph, it is the solution. And that's what I want to see you interpret. Your graph, your solution. It may not be the correct solution, but it's the correct solution based on your graph. So you may graph something wrong, but when you go to answer the question, if you show me where the intersection is according to your graphs, you would only get a point off for graphing the problem wrong, as opposed to some points off for interpreting your solution wrong. So my y value is 2 1/4. Does that equal a negative 3/4 plus 3? A negative 3/4 plus 3 does give me 2 1/4. So it works for one of the equations, but it doesn't work for the other. So it's going to be somewhere right around in that area, but not exactly negative 3/4 and 2 1/4. Okay, so that's all right. It doesn't have to work out perfectly because our graphs aren't going to be perfect. But we did interpret our graph to the right area. I'm going to get rid of this, I think. How about if I just move it over here? Move it off the screen. There we go. Okay, so Creative Crafts gives scrapbooking lessons for $15 per hour plus a $10 surcharge. Scrapbooks Incorporated gives lessons for $20 per hour with no added surcharge. Write and solve a system of inequalities or system of equations that represent the situation and interpret the solution. So let's talk about Creative Crafts. Creative Crafts charge, so Y is going to be our cost, our total cost. They charge a $10 supply charge and $15 per hour. X is going to be the number of hours that the class is, and the Y is the total cost. So that would be our graph for that, or our equation for that. Scrapbook Solutions, or Scrapbook Incorporated, they give lessons for $20 per hour. That's their slope, but they don't have any charges, any additional charges. So they don't charge for supplies. And I know I said surplus and surcharge, but it should have been supplies. I just wasn't reading things right. So on my graph here, I'm going to go by 5s. So here's 5, 10, 15, 20. Okay, so Creative Crafts, my y-intercept is 10, and my slope is 15. So I'm going to go up 15 from 10, and that's going to take me up to 25. Now notice each one of these jumps was 5, right? So that gives me a total of 15 for every one. So this point right here has the coordinates 1, 25. If I continue that pattern, I could get another point up here, and that's 2, 40. And then Scrapbook Incorporated, they have a y-intercept of 0, but their slope is 20. So you go up 20 and over 1, and up 20 and over 1. And we see that these two intersect right here at this point, $240. And we could verify that by putting that in there. 40 equals 20 times 2. So 40 equals 40. And over here, 40 equals 15 times 2 plus 10. So 30 plus 10 equals 40. 40 equals 40. So we have the verification there. What does that point mean right there? Well, that point is when Creative Crafts and Scrapbook Incorporated are charging the same amount. So for 2 hours, it doesn't matter who you go to. You're going to pay the same amount. If you go to Creative Crafts for anything before 2 hours, you're going to be charged more than you do at Scrapbook Incorporated. After 2 hours, Scrapbook Incorporated becomes more expensive and Creative Crafts becomes less expensive. So your intersection between the two lines, or the solution, means that for 2 hours of class, you're going to charge they're going to be charged $40 for either Creative Craft or Scrapbook Incorporate.